Hi, welcome to Armchair Philosophy. I'm Rubin Marshak, and on today's show, we're going to be talking about quantifiers and categorical propositions. To begin, I'd like to make a small correction from my last logic video. You see, when I introduced capital and lowercase lettering, I said that the uppercase letters were objects and that lowercase letters were attributes ascribed onto those objects. But it's really the other way around. So instead of Bill is X being BX, it's really XB. We do it this way because it allows us to say that multiple objects have the same property. For example, if you have capital F and then lowercase SLM, it may mean something along the lines of Lisa, Sally, and Mary are female. But what if I want to make more general statements like some, many, or all? If I were to say everything is good, I can't represent that as GE, or else I'm really saying that there is some kind of object which is called everything and that it has the quality of good. And if I were to list all of the things included in the category of everything and then attach that to a capital letter, well, the sentence would be infinitely long, so we need a way to simplify it. We're allowed to represent a statement as follows. We can have in parentheses an X, and then following that a G followed by an X. This is called a universal quantifier. It says that the X referred to in the G statement is universal. For every X that occurs, that X has the property of G, which in this case is good. So in English, the sentence is, for every instance of X, X is good. Besides universal quantifiers, there are also things called existential quantifiers. Statements such as, someone is coming over tonight, are existential quantifier statements. An existential quantifier states that there is at least one instance where the statement is true, though it does leave the possibility that there are multiple instances where the statement is true. A backward Z is usually placed before the X in the parentheses in order to denote that this is an existential quantifier statement. To return to the example of X where GX, changing the statement to EX where GX changes it into something like there exists something which is good, or at least there is one thing or more things which are good. Another way to say it in English is that something good exists, hence the term existential quantifier. While making a quantifier statement, like in mathematics, you can use parentheses to denote how your terms are applied. For example, in X, where CX and JX and MX, we can say this means there is something which is a cow and jumping, and it can make milk too. But if the statement were instead X, where CX and JX, in parentheses, with MX outside of those parentheses, MX wouldn't fall within the scope of the quantifier. When making a quantifier statement, it's important that all parts of it fall within its scope, so that the terms are well defined and organized. To make the job a little easier, there are some equivalencies that you can use while dealing with more complex statements, especially those that deal with negation or not sentences. For example, everything has purpose could be translated as a universal quantifier statement, X where P of X, where P stands for purpose. Alternatively, it could be stated as nothing exists which doesn't have purpose, which would be not E of X where not P of X. The two are the same exact statement. Displayed on the screen are four quantifier negation equivalencies. The Greek letter phi is used as a placeholder, so feel free to use anything you like wherever it occurs. Now that I've covered the basics on how to make quantifier statements, I'd like to get into the four categorical propositions, which are represented by the letters A, I, E, and O. These are simple sentences which are common and important in Aristotelian logic while dealing with syllogisms. A is a universal affirmative, which implies total inclusion between two objects. An A statement in English might be, all X are Y. An I statement, or particular affirmative, represents a partial inclusion between two things, so some x are y. An E statement is a universal negative, implying total exclusion between the two. No x are y. And an O statement is a particular negative, implying partial exclusion. Some x are not y. To apply this to the quantifiers that I mentioned earlier, take a statement such as, nothing that's free is good, or not EX where FX and GX. This is still an I statement, but in this case it's a negated I statement. What you see on the screen is a list of equivalent formulae to these categorical statements. Instead of x and y as placeholders, you see the Greek letters phi and psi, and as before, feel free to replace them as you wish. As you can see, the A, I, E, O order isn't completely arbitrary. Negated, you just flip it backwards. A is not O, I is not E is not I, and O is not A. And that's all for this time on Armchair Philosophy. I hope you enjoyed this episode. Be sure to like, share, comment, subscribe, and if you really like our stuff, then consider donating to us on Patreon. Also, we have a website with forums on it, which you can chat with us on. And if you want to buy a Milwaukee Atheist t-shirt, you can do that through the website as well. That's all for this time. Bye-bye.